Section B, Ionic Bonds Practice. Atoms will transfer one or more electrons to another to form the bond. Each atom is left with a complete or full outer shell, so it becomes unreactive. An ionic bond forms between a metal ion with a positive charge and a non-metal ion with a negative charge. So we're going to take a look and using the Lewis dot structure and your periodic table, please get both of those out. We're going to take a look at how to draw these. Before we get started, we're going to be drawing Lewis dot structures for both elements in each of these examples. You are going to need to name them using that common basic naming rules. You're going to circle the formula and then you will have the equation. So let's take a look at sodium and chlorine. Sodium has one valence electron. So we will draw a dot for our Lewis dot structure. Chlorine is in group 17, so it will have 7 valence electrons. So look what's going to happen here. We're looking at the valence electrons. More than likely, sodium is going to lose this one valence electron because it is much more difficult to gain 7. Chlorine already has 7. So this is why sodium and chlorine end up bonding. Sodium will lose its electron, which makes it positively charged. It is a cation. I don't have to write the number 1. How do I know that has that positive charge? Go back and take a look at that other video over ions, and that will go over it with you. We add a plus sign here because we're going to add sodium plus chlorine. So what charge does chlorine have? Chlorine is gaining this electron or gaining this negative. So it's gaining 1 negative. So we only have to have 1 of each to end up balancing those to 0. And the result is NaCl. Go ahead and put a circle or a box around that. And then you're going to need to name it using your naming rules. First, we write down sodium. And then we have chlorine, and we change the ending of chlorine to chloride. So on each of these examples, I want to see you write the symbols, the Lewis dot structures, and then you're going to draw an arrow to see where these electrons are going to be lost or gained. Then you will write down the oxidation state of both with a plus. You want to make sure these are balanced to 0. Plus 1 minus 1 equals 0, so that is balanced. So we have 1 each of sodium and chlorine. And then be sure and write the name, sodium chloride. So I want you to go ahead and look at your periodic table. Find the number of valence electrons for magnesium and iodine and do the Lewis dot structure. Pause the video so you can do that. So magnesium is in group 2. Iodine is in group 17. So magnesium has 2 valence electrons and iodine has 7. So we can know that one of these valence electrons are going to be lost here to iodine. So when that happens, that gives us the full 8 for iodine. But we still don't have this one balanced. So we are going to need to make another iodine Lewis dot structure. And we will pull that one down to there. Now, we know that magnesium does not need 6. We don't show that first level already has the 2. And now we know that iodine both have 8 there. So let's see how to write this. So what is the oxidation state of magnesium? Magnesium is losing these negatives, so it's ended up with a positive 2 charge because it has lost 2 negatives, so we have two positives. Now, we have iodine, and iodine is gaining 1 negative, but how many iodines do we have? We have 2 iodines. So what does this result in? Put your resulting arrow there. You end up with 1 magnesium and 2 iodine, because we want to make sure those balance out to 0. Plus 2 minus 1 gives us a 0 charge, so therefore it is balanced. And then you want to go ahead and write the name down for it. Magnesium iodide. Potassium iodine is pretty straightforward. Go ahead and pause the video, make the Lewis dot structure for each of those, write the equation down, and write the name, and then come back and double check it. Potassium has 1 valence electron in group 1. Iodine has 7 valence electrons in group 17, and we know that potassium is going to lose this 1 electron to iodine. So in potassium we have the oxidation number of +1, and iodine we have the oxidation number of -1. But remember, the 1s are implied. Now, the result is called a product. We just have 1 of each because +1 and -1 equals 0, so that's balanced, and then write down the name. Potassium, and then you take iodine and change the last to IDE, potassium iodide. Go to example 4, find both of those on the periodic table, write the Lewis structure. Let's see how those valence electrons will transfer, and write down the equation or the chemical formula and the resulting product and the name, and let's see how you do. Sodium has 1 valence electron. Oxygen's from group 16. It has 6 valence electrons. We know that sodium will lose this. It's easier to lose 1 than to gain 7. But we have a problem here. Notice what we've got going on here. We only have 6, so whenever we take this 1, we still need another one. Well, we have an unlimited amount. We just draw another sodium. Let's write down the chemical formula, just like we did on B2. Sodium is going to lose these negatives, so we end up with a positive charge on both of those. Plus our oxygen has gained 2 negatives. Let's see if this is balanced. +1 plus 1 is +2. +2 minus 2 equals 0. So that is balanced. We don't need any more, and we know it's balanced too because we have all those accounted for. So we have 2 sodium and 1 oxygen. Let's go ahead and write down the name and check it. Okay, B5 is calcium and chlorine. I'm just going to go ahead and work this. I want you to pause the video, you work it, and then double check your answer. Calcium's from group 2, so it has 2 valence electrons. Chlorine is from group 7. It has 7 valence electrons. We'll lose 1, but we still have another one we have to get rid of. So therefore, we have an unlimited amount of these. We can go ahead and add another chlorine. And now let's see if we've got that balanced. These 2 are taken off, so we have a full inner shell. We end up with 8 here and 8 here. Calcium ends up with a positive 2 charge. Chlorine ends up with a -1. The other chlorine is -1. +2 plus -1 plus -1 equals 0. So that's balanced, so we can write our product. There's only 1 calcium, and there are 2 chlorines. The name, calcium chloride. Hopefully you're starting to see the pattern on this, and it's making sense. Let's go to our last one, aluminum and chlorine. go ahead and find those on the periodic table. And let's see how you do on this one. It's a little bit tougher. Chlorine is from group 17, so it will have 7 valence electrons. Aluminum is from group 13, so it will have 3. We know this one electron is going to go ahead and go over to chlorine, but we still have 2 additional. So we'll go ahead and do one here. And that last one can go to our last chlorine. So I want you to go ahead and write down the chemical equation and see how that balances out. Aluminum's oxidation state is +3. Why is that? Because each of these negatives have left, and so we have an overall +3 charge. Each chlorine has gained 1 negative. So let's see if this balances. +3 minus 1, minus 1, minus 1. Yep, it does. So our resulting product, Al, 1 aluminum, 1, 2, 3 chlorines. And write the name, aluminum chloride. So you have one challenge here that I want you to do. What are some other ionic bonds that can be formed by the elements up here that you see? Remember, you need a metal and a non-metal to make an ionic bond. Write the chemical formula for the compound and its name. So use any of the metals and non-metals up above to do this challenge, and then I have one other challenge. So go ahead and pause. Do challenge 1, and then I'm going to give you a challenge 2. So, challenge 2. Iron is a transition metal. Transition metals can have varying valence electrons. In this case, I'm saying that iron has a +3 charge. You need to go ahead and do oxygen, just like we have this whole time, and do the Lewis structure. Try to figure out what the Lewis structure looks like with iron being +3. And see if you can't end up with writing the formula, doing the Lewis structure, everything that we just did up here. See if you can't get a balanced equation from this. And I'll be anxious to see how you come up with it. Good luck.